Composition is one of the most important principles you can apply to Node.js development. Composition is the practice of splitting your application into several smaller, simpler parts, making each part easier to understand, develop, and maintain. It also makes those parts easier to test and improve independently. The opposite of composition is a big, monolithic codebase. Monolithic codebases don't work well when you need to make a change, they don't work well when you need to test a specific part, and they definitely don't work well when you need to analyze performance and find what is slowing things down. The Node.js platform was designed to encourage composition. And NPM, the Node.js package manager, is the engine that makes it practical. NPM is a module publishing service where you can download other people's modules and publish your own. There are tens of thousands of modules available, which means you don't have to reinvent the wheel for most common tasks. Using existing, battle-tested modules means fewer bugs, more users finding and fixing issues, and faster improvements arriving in your codebase. But using NPM well means being disciplined about it. Don't just grab a module, track changes carefully, and always keep recent stable versions. If a dependency hasn't been updated in a year, you'll spot a problem later and have a very hard time figuring out what changed between versions. Node.js modules tend to improve over time and API changes are not rare. Always upgrade with caution, and don't forget to test after upgrading. When you choose an NPM module, you're essentially hiring it as a component of your system. Treat it like one. Code separation is a discipline. In Node.js, the guideline is simple: you should not have files bigger than 5 kilobytes. If you have a file that large, you should think seriously about splitting it. Also, as a good rule, each user-defined object should have its own file, named accordingly. A useful sanity check: can someone new to the application read and understand this file in under 5 minutes? If not, it's too complex. It will be harder to track bugs and harder for the engine to optimize. Remember that when your application becomes huge, even you will be like a new developer when opening a file to fix something. Now, about asynchronous tasks. The Node.js platform is designed to be asynchronous, so you shouldn't fight it. Embrace it. The async library is a simple and practical way of helping developers work with asynchronous code. It provides methods like map, reduce, filter, and each, but for iterating asynchronously, running serial or parallel tasks cleanly. Without something like async, serial tasks enforce nested callbacks and lead you into callback hell. The platform also follows the error-first callback style, and this rule is critically important. Your callback should always reserve the first argument for an error event, even if it's always null. This allows your function to be used with the async module and makes it predictable for every developer who calls your code. Always reserve the last argument of the function as the callback. Never define arguments after your callback. And remember, callbacks are called outside the scope where they are defined. You cannot wrap them in a try/catch block and expect it to work. Throwing an exception without catching it in Node.js will trigger an uncaught exception event that can crash your process. Library functions, from packages like lodash or underscore, are an important tool in your arsenal. They handle repetitive tasks with built-in optimizations you don't even have to think about. Finding an object in an array, mapping an array to keys, filtering collections, these are one-liners in lodash with good internal optimizations. But use them carefully. Some modules are designed for developer convenience, not for performance. If you call the same utility function multiple times in a hot loop without understanding its complexity, you'll pay the price later when your application is under load. Read the documentation. Know what you're calling. Now for function rules, and this is about writing code that is maintainable and optimizable. Rule 1: always name your functions, especially closures used as callbacks. Names appear in stack traces. They help a new developer understand what the function is supposed to do. Avoid long names, but don't use anonymous functions where a name would clarify intent. Rule 2: don't nest conditions. Return early. If a condition must return false immediately without an else block. Every extra nesting level increases cognitive load and reduces readability. Rule 3: create small and simple functions. Don't span functions for more lines than your screen can handle. If a task can't be reused, split it into smaller ones and publish them. This allows the engine to optimize the smaller functions independently. Finally, testing your modules is often neglected but critical. Start writing tests early, even 1 or 2 will grow into a full suite. When you find a bug, write a test case for it. Use code coverage tools like Istanbul or Discoverage to see how much of your module is actually being exercised. Test your dependencies for improvements. Dependency version management is one of the most important long-term practices in performance work, because modules are refactored and performance is boosted over time.